Thank you. Functions. Let's go. Uh, thank you. Functions. Uh, the first one that we're going to talk about, it's a straight line graph or a straight line function. Straight line graph, straight line graph. So the straight line graph has the following standard form: y is equals to mx plus c. So we can say plus c or q. When we do functions, what is important, or the most important thing that we can grab here, is the standard form of the graph. Knowing the value of m, what m stands for, and what happens if m changes, and then knowing the value of c and what happens to the values of c as c changes. So knowing that part, it's that is the only thing that will help us to understand the graph. By just looking at the equation or by just looking at the graph, we will be able to tell the value of m and c. So in this standard form, y is equals to mx plus c. M is the gradient. M is the gradient or slope. M is the gradient or what? Or slope. M is the gradient or slope. This equation of a straight line will be dealt with also when you do analytical geometry. It will be dealt with analytical geometry. So M is the gradient or slope or the coefficient of x. And then you C is the y intercept. Or before we talk about C, can we talk about M in details? Let's finish all the properties of M. So M is the gradient or slope. Another thing about M is that M determines or the gradient determines the shape of the graph, determines the shape of the graph. Yes. As I was saying that M determines the shape of the graph. So meaning if you want to know the shape of the graph, we'll have to look on the value of M. So if M is greater than 0, that is to say positive. If M is positive, then the shape of the graph will be as follows. The shape of the graph, if M is positive, the shape of the graph will be as follows. We will have an increasing graph. Why we are saying an increasing graph? If you look at the direction of the graph, it's increasing from left to right. The graph will be increasing. If M is positive, it means the graph will be increasing from left to right. meaning you will be like climbing the stairs, climbing the stairs, climbing the stairs. If M is positive, it means see now this one. You will be like climbing the stairs. If we can redo it again, it will be like you're climbing the stairs or that mountain. Yeah, if we can try to draw that mountain. If M is positive, it will be like you're climbing the stairs. So the shape of the graph will be the slope of the graph is positive. That is to say, M is greater than 0. That's when M is positive. So the shape of the graph will be like this. Let's see, is Singh coming back? Not yet. Not yet. It's fine. Then if M is negative, if M is negative, if M is less than 0, that is to say, if M is negative, then the shape of the graph will be going down from the stairs. If I can put something like this, there you are. We will have a decreasing function. If M is positive, we'll have an increasing function, increasing function, increasing function. And then here we'll have a decreasing function. There you will be going down from that cliff or those stairs. That is M, it's negative. So as you go, you have to climb the stairs going up. The gradient of the stairs as you climb, it's positive, but as you go down from the stairs, the gradient is negative, or the slope is negative. As you go down from the cliff or a mountain, or going down from a building, the gradient that you'll be moving on, it's negative. That is if M is what? It's negative. Okay, Chendo?
Okay.
Yes. Then the other part, it's C. What is C? What is C? C is the y-intercept. C is the y-intercept. So when we say C is the y-intercept, we are saying C tells you where the graph will touch the y-axis. The point where the graph touches the not the x-axis, sorry, the y-axis. The y-axis. The y-axis. The point where the graph touches the y-axis. Okay, Tendo, just a little, let me try to reach out to Ntabiseng.
Okay.
Yes. Oh, there she is. She's back. She's back. She. So, this is where we started. This is where you left in Ntabiseng. We're saying that M is the gradient or slope of the graph, or determines the slope. M also determines the shape of the graph, meaning that the value of M will tell us what is the shape of the graph, whether the graph is an increasing function or a decreasing function. So if m is positive or if m is greater than 0, we will have a graph of this shape in such a way that it will look like you are climbing the stairs or you are climbing a cliff.
Mm-hmm.
So that would be the shape of the graph if m is positive. So we call it an increasing function. If m is negative, it means we will be going down from the cliff or going down from the stairs, meaning the shape of the graph will be in this way. We will have a decreasing function. We will have a decreasing function. If m is what it's negative. So the other thing that we need to talk about was the value of c. C is the y-intercept. What is the y-intercept? The y-intercept is the point where the graph touches the y-axis, meaning the value of c will be telling us where will the graph touch the y-axis. Okay.
Mm-hmm.
Let's see, is there anything that we are leaving behind on this graph? Yes, the domain and range of this graph, the domain and range of a straight line graph. Oh, the other thing before we go to domain and range of the graph, let's also take note that the y is the output value and x is the input value. Okay. So meaning x is an independent variable and y is a dependent variable. Okay. The other thing that we need to talk about on this graph, we'll have to sketch it first so that we can explain this thing. The domain and range. Domain referring to the input values and then range referring to the output values. Let's have an example and sketch the straight line graph straightforwardly, nicely. Example. Sketch the graph of the first one. Let's look at the first one, number A. Going to have y is equals to 2x plus maybe 2, something like that. And then let's have this one, and then number B, we'll have our second one, number B. We're going to sketch maybe the graph of y is equals to negative 2x plus 2. I want us to talk about the sketching of the straight line graph. Please take note, it's a sketch. It's not an accurate drawing. It's a sketch. It's not an accurate drawing. So let's sketch the first graph. So we're going to do our Cartesian plane. If we can have, thank you. Let's have our Cartesian plane. There you are. And then this is our x-axis. That one was our y-axis. Yeah, something like this. Thank you. Thank you. Okay, this is our y-axis. This is our x-axis. This is the origin. Remember, we're doing a sketch here. So if we look at our equation in A, we will see that the gradient is positive. It's positive 2, meaning the shape of the graph must be in this way. Okay.
Yes.
That is number A. We must be climbing. This is the shape of the graph. The other thing that we notice in this equation, okay, the gradient is positive. That's what I'm concerned with. And then the other thing is that your y-intercept, the graph is touching the y-axis at +2. So I will call this one my +2 here. This is the point that I need. Then the next thing, I'm sketching the graph. The next thing what I'm going to do after I indicate this is +2, I'm going to sketch my graph. Here you are. Something like this. Yeah, something like this. Something like this. Yeah, I can make it longer. Remember, this is a sketch. It's not an accurate drawing. Okay. This is a sketch, not an accurate drawing. Then the next thing that I'm going to do, I'm going to calculate my what? My y-intercept, or not y-intercept, x-intercept, by putting y is equal to 0, because on the x-axis the value of y is 0. The value of y is 0 on the x-axis, meaning if I want to know the value of x at this point where the graph is touching the x-axis, I need to substitute the value of y to be 0. So let's do that. Going to say 2x plus 2 is equals to 0, solving for the y-intercept. Then I transpose to that side. 2x is equals to -2. Then I divide both sides by what? By 2, so that I can be left with x on the left-hand side equals to -1. Therefore, hence here, my value of x at the point where the graph is touching the x-axis is -1. Okay, let's see how is this thing marked. The shape of the graph, 1 mark. Indicating the y-intercept, a mark. Then the other mark will be indicating the x-intercept, a mark. So if you check with me, by just being able to interpret the equation of the graph, you will be able to draw the graph without doing this calculation.
Oh, okay.
Okay. So these calculations, it comes after. But sketching the graph has to do with understanding the equation. Okay, let's go to the next equation, the second equation. That's why if we were to go to to the previous question, the one that we have there, you will see sketching the graph, it's around 3 marks, 4 marks. Okay, let's look at this one. Sketch the graph of this one, that's number B. If we look on this one, we will see that the gradient is negative. If the gradient is negative, it means we're going to have a sketch that is like this. Okay, so, and another thing that we notice is that it's touching the y-axis at +2. Do you see that? So there, there we are. It's going to touch, it's going to pass there. Then the next thing, we draw our sketch. We know the shape, we know it's touching the y-axis. So let's go. Thank you. There you are. And then this is your this is the equation. This is number A. This is number A. This is number A. This is number B. Then the next thing what we're going to do, we're going to solve for x here by putting y is equal to 0. Yes, we will get x is equal to 1. Because if we can do it there, we'll get x equals to 1. Let's go. -2x plus 2 is equals to 0. At this point, the value of y is 0. Then -2x is equals to -2. Dividing by -2 both sides, x is equals to 1. Okay, so meaning the graph is touching the y-axis at +1. Okay, now we've drawn our graphs. Now let's talk about the domain and range. Remember, the domain is the input value. If there are questions, is this sketch correct? If I do this sketch, if I do such a sketch, will I get all the marks? The answer is yes. You will get all the marks.
Say.
Yes. Yes, I'm listening.
Say.
Yes, Ntabizeng.
Isn't like B a -2? Isn't it supposed to be like on the other side, like underneath?
Underneath or like below the
Like,
x-axis.
yeah.
No. Remember, this is a straight line graph. So in a straight line graph, M tells us whether we are climbing or we are going down.
Okay.
So M is positive, we are climbing the stairs. Can you see that? So if I were to draw maybe your cliff. If I were to draw your cliff, look. If you look at this graph, your first graph number A, you are climbing this cliff or this mountain. And then if you look at, if I can like try to shade here, look. If you look at this one number B, because the grind is negative, now you are going down from the cliff. Okay. That this I would draw the straight line graph. So I want us to close the part of straight line graph by talking about the domain and range. So the domain are the input values. So to determine the domain of the graph, we need to look at the sketch. So if we look at both our sketch, we'll see that the sketch, this graph, then the first graph number A, if we look at it like on the from the left hand side to the right hand side, you will see that as it moves up and down, it is also expanding left and right with no, it's moving to the left and to the look. If I can just do something like this, if you look here, it's at negative maybe -3. If you look here, it's at negative maybe -2, -1. Maybe here it's at negative 0.5 and then 0 and then negative 0.5, +1. If you look at the arrow it's indicating that the graph is still continuing going to which side? To that side. You look at this arrow saying that this graph is continuing to go that side. Meaning, therefore, if we look at the domain of this graph, the first graph or the straight line graph, because even if we look at number B, we'll see that it's continuing left and right with no limitation. It will mean, therefore, the domain of a straight line graph always, the domain of a straight line graph will be X element of real numbers. What are real numbers? All numbers that you can think of, decimals and integers. So all numbers can think of, the graph is continuing left and right up to infinity. So that is the domain of the graph, X element of real numbers. Then we look at the range, the movement of the graph up and down. The range is talking about the movement of the graph up and down. Is domain, the range, always, if we ask you, unless we give you a restriction. But if we didn't give any restriction, this is very true. So the range of the graph, we're looking at the values of y up and down. If you look at both graphs, they are moving up and down up to infinity with no limitation. At those arrows indicate that we continue going up, we continue going down. So it means the range of the graph will be y element of real numbers. So in short, this is a summary or a very brief summary of a straight line graph. So if we ask you the domain and range of a straight line graph, this is what we are expecting, which is a very rare question since you are doing pure maths. In technical maths, we will ask, but in pure maths, it's very rare to ask you the domain and range of a straight line graph because it's something that we believe it's very obvious. Let's move to the next graph, which is a parabola. very interesting. Also, the equation or the standard form of the equation, it's important. Let's go to a parabola. I hope and believe that we will do it much quicker and faster. Number 2, parabola. Please move with me, or quadratic function. We call it a parabola or quadratic function. Parabola or quadratic function. So we are in grade 10. So in grade 10, we will focus at the following. The equation of our parabola in grade 10 is y is equals to ax squared plus or minus q or c. Plus or minus q or c. So, okay, as usual, y is the output and then x is the input, as we know. But what is a, or what does a do? A determines the shape of the graph. A determines the shape of the graph, and then A determines the shape of the graph, and then okay, A determines the shape of the graph. Then what we're going to do, if A is positive, let's write the positive, then positive, then the shape of the graph is concave up. Then the shape of the graph is concave up. That is to say, the shape of the graph will be like this: concave up, a greater than 0. Concave up. And then if a is negative, less than 0, negative, then the shape of the graph is concave down. What are we saying by this? Let's show you. If A is negative, the shape of the graph will be concave down. This is what we are saying. A less than 0. Okay, the other thing about the value of A is that as the value of A increases, the graph gets narrower. Remember, A determines the shape of the graph. As the value of A increases, the graph gets narrower. As the value of A decreases, the graph gets broader. So we will illustrate this by this. Another thing, okay. As the value of A. As the value of A increases, as the value of A increases, as the value of A increases, the graph gets narrower, narrower. Then the vice versa will be the case, meaning that as the value of A decreases, the graph will get broader. So if we can illustrate this by as the value of A increases, as A increases to that direction, as A increases, as A increases that direction, the graph is getting narrower. So we will have, we'll use a smiling face. There is your first graph. It's broader. And then let's try to make, how many did you take? 1, 2, 3. So you are going to take, what are you doing now? Let's have another one here. Yeah. As A increases, look at this one. Okay. As A increases, thank you. As A increases, you see that it's closing, it's closing, it's closing. As A increases, it's closing. The graph is getting narrower. It was broader this side. If you look, as A increases, the narrower the graph. As A increases, the narrower the graph. As A increases, the narrower the graph. As A increases, the narrower try to write nicely here. As A increases, the narrower the narrower the graph. So as A decreases, the broader the graph. So if we move from the opposite direction, as A decreases, the broader the graph. Okay.
Okay.
So we lost Tabi saying, I don't know. Okay, it must be load shedding. Okay. Tendo, otherwise, are you still happy with this?
Yes.
Okay, so as A increases, the graph it's getting what narrower. We'll show you as you go there. So this is what the value of A does. So if A is negative, the graph is concave down, it's that face. And then if A is positive, the graph it's what it's concave up, it's a smiling face. So we will be looking at the value of A to know whether the graph is concave up or concave down, and also to know whether the graph it's narrower or broader. But whether it's broad or narrower, we must be comparing it with the other graph. So when you compare the two graphs, I write down the equation of y is equals to 2x squared and y is equals to 1 over 2x squared. What we see in these two functions is that the first graph it's narrower compared to the second graph. Both graphs are smiling face. Both graph has the y-intercept of 0. So what is different between the two graphs is that the other one, it's narrower. The first graph, it's narrower compared to the second one. The second one, it's broader. Okay, it's Tabi saying it's back. She must be back. Okay, thank you, Tabi saying you are back. Okay, we'll do this part on the example, on the example as we compare the graphs. Then let's talk about the value of Q very straightforwardly. So let's talk about the value of Q. Your Q is the y-intercept. Your Q is the y-intercept. From the previous notes, I hope we understand that the y-intercept is the value of y, or is the point where the graph touches the y-intercept. Okay.
Okay.
Q is the y-intercept. And then another thing is that in the equation, y is equals to ax squared plus q. Q is the turning point. Is the turning point. Q is the turning point. In this equation, y is equals to ax squared plus q. Q is the turning point until we are up to grade 11. We'll tell you the new turning point. It will no longer be q. Q is the turning point, meaning q determines the value of y, where the graph will turn. As you can see, we have a turning point here. We have a turning point there, we have a turning point there, we have a turning point there. So the value of y at the turning point will be determined by q. Oh, another thing is that, no, not q. Q is the value of y, is the value of y at the turning point. Q is the value of y at the turning point, usually abbreviated as TP. Q is the value of y at the turning point, not necessarily the turning point, but is the value of y at the turning point. After we discuss the turning point, what else we need to talk about? The range and domain. Let's start with the domain. Our domain of a quadratic function, the input values, as you can see, the graph, it's moving left and right. The domain is x element of real numbers. And then our range, the range of a quadratic function will depend on the value of a. Range. So let's go. If a is positive, if a is greater than 0, then the range will be y. This is a smiling face, remember? Y is greater or equals to the value of y at the turning point, which is q. The value of y at the turning point, which is q. Y is greater or equals to the value of y at the turning point. And then, meaning if it's a smiling face, if we can illustrate this, what we are saying here, look at your graph, look at your graph. It will be like this. So this is a smiling face. And then we're going to have the value of Q here. Is the value of Q. And then if you look at your graph, it's going up from Q. It's going up from Q. It's going up from Q. So it's going up from Q. There it is. So if you look here, you will see that, okay, the range or the values of Y will start from Q going up from Q going up. So that's why I'm saying Y is greater than or equals to Q. And then if it's a set phase, if A it's negative, then your range will be Y it's less or equals to the value of Q. If we are to look at this shape of the graph, the shape of the graph will be like this. Then if you look here, this is the value of Q. And then it's going down. Check, it's going down. So this will be your turning point, your y-intercept. Then from this point, the graph is going down, meaning the values of y will start from Q going down. That's why I say y is less or equals to Q. That is the range. Another thing that we must not forget, or let me address it on the example. Let me address it on the example. So let's have our first example. First example on sketching the graph. Example. Sketch the graph of. Okay, let's go. Sketch the graph of y is equals to, or let's have multiples of them. A, the first one. Can we call this one maybe f of x? F of x is equals to maybe 2x squared. 2x squared, it's a smiling face, plus let's start with this one, 2x squared. Yeah, let's start with this one first, then we can discuss some effects. Number B, let's have maybe g of x is equals to maybe x squared minus 1. And then number C, let's have h of x is equals to what? Negative x squared plus 1. Let's look at this 3. Yeah, maybe we can have also number D. We're going to draw all these graphs on the same set of axes. Number D. In number D, let's have more or less the same thing, but let's have k of x is equals to 1 over 2 x squared. Okay. We are sketching the parabolic graph. So if we can have this equation here on top, y is equals to ax squared plus q, so that we can be able to see what is the value of a in each equation, what is the value of q in its equation. So on the first graph, number a, we see that the value of a is what? It's 2, it's positive. But the value of q here is 0. That's why it's not there. Taking note that q determines the value of y the graph will touch the y-axis. Meaning, if it's not there, it means therefore the graph must touch the y-axis at what? At 0. So if we were to sketch our graphs here, let's have a Cartesian plane. Let's hope it will serve us well. Let's hope it will serve us well. I want to do a rough sketch so that I can be able to liberate you. Let's do a rough sketch, not an accurate graph, so that at least you can be liberated when we do the previous question papers origin there. So looking at this graph, the first graph, f of x, I want to draw the first graph. The first graph, it's touching the y-axis at 0. Since the value of q is 0, it's not there. It's touching the y-axis, meaning it will pass through the origin. It will pass through the origin. There it is. Then going back to the value of a is positive, meaning this graph is going to be concave up. So by just looking at the function, I can just draw something like this. Something like this. I can just draw something like this. Not nice. Not nice. Something like this. Thank you. Yeah, just something like this, roughly so. So this will be my f of x. Then if I can go to number B and do my second graph there. In number B, what I see is that the value of A is 1. Can you see that? The value of A is 1. That's why it's not written there. The value of A is 1 in B. Then what I see also is that my graph is touching the y-axis at -1. It's touching the y-axis at -1. So I will say this one is my -1. So my graph is going to start here. It's going to touch the y-axis at -1. Then my turning point will be here at -1, since q is -1. Okay. Then by looking at the value of a here, the value of a here is 1, meaning this graph must be broader compared to the first one. Meaning these two graphs must not touch each other. This one and this one cannot touch each other because this one is broader. This one is narrow. So this one is inside of this one. So there is my second graph. The smiling face because A is positive. Okay, it cannot have curves like that. There it is. Then this one is my g of x. Something like this. Then what I see, look, on this first graph, we didn't have to bother about the x-intercept, but this one, we need to calculate the x-intercept on this one. We need to calculate the x-intercept. What do we see here? We see that the equation is a difference of 2 squares. The difference of 2 squares, meaning to calculate the x-intercept here, we can put g of x stands for y, to be 0. G of x to be 0 and solve for x. So if we solve for x here from this equation, x squared minus 1 is equals to 0. Then we can factorize here, since the difference of 2 squares, x minus 1 x plus 1 equals to 0. Therefore, x is equals to positive 1 or x is equals to negative 1. Where is negative 1? This side, negative 1. This side is positive 1. Okay.
Okay.
Then let's go to our third graph. I hope you can see that it is very much straightforward to draw a parabolic graph. It's very much straightforward. Let's go to the third graph. On the third graph, we have h of x there. What we see is that a is negative, meaning our graph is going to be concave down. It's a set face, concave down. Where is the graph touching the y-axis? At positive 1. So I'm going to have positive 1 here. This positive 1 is going to be what? My turning point. Okay. So this positive 1 is going to be my turning point. This is going to be concave up, concave down. What about the broadness of the graph between B and C? The broadness of the graph is the same. It's just this one is concave down, but as it go, the length from the y from what, from the y-intercept to the x-intercept, it will be the same, meaning that this graph is going to pass here. They're going to have the same x-intercept, though it's concave down. We will calculate it and prove it. So it's going to have something like this, a concave down graph passing there. This is going to be our what? Our number C. We're going to call it h of x. So let's see whether this is true. Look, it's negative, concave down. What is the value of a? The value of a is 1. Whether a is positive or negative, when it comes to broadness, it has nothing to do with whether you are positive or negative. So meaning in our notes there, we're supposed to indicate also that as a increases, irrespective of the sign, as a increases, irrespective of the sign, the narrower the graph. Meaning that when you talk about broadness of the graph, 2 and negative 2 have the same effect, or they have the same broadness on the graph of the parabola. This one will be concave up, this one will be concave down, but the broadness of the graph will be the same of the two graphs. It will be the same. So let's calculate the x-intercept of this graph of ours, the concave down graph, and see whether our points are correct. Let's see. Negative x squared plus 1 equals to 0. Then let's transpose. Negative x squared is equals to transpose positive on that side, negative 1. Or we can just do it the way like we did that other one. The coefficient of x squared is negative 1 or negative. Let's remove that negative by dividing each term by negative. We divide each term by negative, we got x squared minus 1 equals to 0. That is 0 divided by negative 1. Then we factorize. See, we have the more or less this, we have the same equation now. By just dividing by negative, we have the same equation. Therefore, the answer will be the same. It will be the same because we have to factorize here. X minus 1, x plus 1 equals to 0. Therefore, x is equals to positive 1 or x is equals to negative 1. So more the same. Okay.
Okay.
Then let's move to our last friend there, number what? Number I'm going to throw you with break. Number D. K of x is equals to 1 over 2x squared. So what do we recognize here? We recognize that the value of q is 0, meaning our turning point will be here at the origin. That's how I read the graph. The next thing is the value of A. The value of A is positive, meaning I'm going to have a smiling face. Okay, the next thing, I look at the value of A, the broadness now. So this graph, it's broader. It's broader compared to number A, number B, and number C. This graph is broader. So I believe that at some point it will intersect with G. At some point it will intersect, yes, it will intersect with H, yes, there's no way. Then it will only intersect with what? With F. Where? At the turning point here, at this point only. Otherwise, they won't touch at any point at any time. So let's see at the graph. This is going to be the graph. It's broader. It's broader. You see? This is our graph. It's broader. This is our graph. You see, it's opening, it's welcoming. It's much broader compared to all of them. So this one is your what is your K of X. Any questions, Tendo?
No.
Are you happy?
Yes.
Can you draw the parabolic graph now?
Yeah, I think so.
If I ask you to sketch, you will be able to sketch, Anne?
Yeah.
Because we do have questions asking that. So these are the two graphs that we discussed. We are supposed to move to exponential and hyperbola. But I have this belief that it will be unfair of me to do exponential and hyperbola at the same time, doing all the graphs at the same time. So let's reserve them for tomorrow. At the moment, can we do some questions on these graphs, please? On these two graphs, let's do some previous questions. There you are, our first friend there. There is something that we didn't discuss, but we will touch on it as we do these questions. Let's see. Look at 6.1 there. What are they saying? Can you see the question?
Yeah.
Yes. Let's look at 6.1 there. They are saying determine the equation of the graph of F and G. Okay, so I want us to look at F and then G. So looking at F is a parabolic graph, meaning F as the equation F of X is equals to AX squared plus or minus Q. Then let's see. Determine the equation of F and G. So F is a parabolic graph, and then G of X is a straight line. That is mx plus what? Plus C or Q. So here it's our parabolic graph. By looking at this graph, I can tell that A is negative. By looking at this graph, this one, I can tell that A is negative. Can I move this friend of mine to the left? Just a second, because he's disturbing. You're disturbing. Let me move you to the left. Format. You are not here. Where are you? I want to move you. Okay, it's fine. We'll work like this. It's fine. This one, it's a parabolic graph, and then it's concave down, meaning the value of A is negative. Then the other thing that I will look at is the value of Q. The graph is touching the y-axis at 8, meaning Q is 8. 1 mark in. Without any calculations, Q is equals to 8. Since the graph is touching the y-axis at 8. Then what will I do to find the value of A? We have the value of Q. After we find the value of Q, we can now do what? We can now substitute one of the coordinates, whether it's point B, since point B it's in F, as you can see there, and also point C. But point B here it's indicated, which is an advantage for us. We'll use point B to solve for A. But what we know is that the value of A must be negative since the graph is concave down. Okay, let's see solving for what? For A. So at the moment we're 6.1. This is not visible. 6.1. At the moment, what we see is that in 6.1 we have f of x is equals to ax squared plus 8. We agree on that?
Yes.
Yes, it's plus 8. Then let's substitute point B. In point B, substitute what? Point B. Substitute point B. Point B, which is what? -2 and 0. So what we see in point B is that x is -2 and the value of y is 0. That is f of x is 0. So if you substitute there, put 0 equals to a, open bracket, -2, that is the value of x squared, plus 8. Substitute what? Substitute point B on f. On f of x. Then we have to solve now for a. So take a this side. This is going to be -8 is equals to, this is going to be 4 for a. Then divide both sides by what? By 4. A is equals to -2. Yes, a is negative as we have indicated since it's a set face or concave down. Now our equation of f will be as follows. F of x is equals to -2 open bracket, not open bracket, -2 x squared plus 8. So what we see is that if they ask us to determine the equation of a parabola, we need to look for a and q. That's what we did there. Then we got the equation. Let's see. We got 1 mark for the value of q. The value of q 1 mark, the value of a 1 mark for sure. Substitution must give us also a mark. Then let's give it 1 mark here. Then let's go to what? To the straight line g of x. In g of x, what do we see? Let's look at the gradient. Is the gradient positive or negative? Tendo, is the gradient positive or negative on g of x on the straight line?
I think it's positive.
Okay, why are you saying it's positive?
Because it looks like it's increasing.
No. Look, this is how I see it. I'm going down. I'm climbing the side. So we're not climbing, we're going down. And then another thing, how do we see whether it's negative or positive? This graph of yours, it's decreasing from left to right. Look, it's decreasing, it's going down from left to right. So that's how we see that this is a decreasing graph. It's decreasing from left to right. This is my left side. It's up. My left side, it's up. Whereas my right side, it's down. Do you see that?
Okay.
So it's a decreasing graph. Let's look at an increasing graph. Something like this. Look, on your left side, it's what? On your left side, it's down. On your left side, it's down. But on your right-hand side, it's up, meaning it's an increasing graph. As we move to the right, we are increasing. As we move to the right, we are decreasing on this other one. Okay.
Okay.
Yeah, that's how you see it, whether it's increasing or decreasing. So this one is a decreasing graph, meaning the gradient must be negative or the value of M must be negative. Then if I may ask, Tendo, what is the value of C?
The value of C is 8.
We are on this graph now. We are on the straight line.
Oh, okay.
We are on the straight line. What is the value of C again? Remember, C is the value of Y where the graph touches the Y axis. So where is the graph touching the Y axis?
Is it at 4? -4.
Yes, the graph is touching the Y-axis at -4, meaning therefore C is -4. So if we've got C being -4, we're going to use this coordinate, this one. Again, since this point, it's at point, it's on your G of X, it's on your straight line graph, we're going to use this point again to solve for what? For M. And we believe that M is going to be negative because this is a decreasing function. Okay.
Okay.
So let's go for G. Let's solve for G. If you can put it there. And then our equation at the moment, G of X is equals to MX minus 4. Okay.
Okay.
If I can just write it just here. Thank you. Our G of X is equals to MX minus 4. That is the value of C. We got 1 mark already. C is equals to -4. So how many marks do we have now? 3 marks. 2 marks was for free. Then let's substitute the point B in G. So what we see in point B is that the value of Y is 0 and the value of X is -2. Our Y is G of X, so it's going to be 0 equals to M, which is stand for gradient. M, which stands for gradient, and then our X is -2 minus 4. Okay, then let's take the negative for that side. Then this is going to be +4 is equals to -2M. Let's divide. Let's divide by what? By 4, both sides. Let's divide by 4, not by 4, by -2, both sides. Our M is going to be what? -2. There we are. The gradient is negative since the function is a decreasing function. Remember on our notes, if you check there. Then what is the equation? The equation, let's check the equation. The equation is going to be G of X is equals, what is the value of M? -2X minus 4. That is the equation of our straight line. Then we'll get all the 5 marks. Okay.
Okay.
Now let's move to 6.2. The length. Or before we talk about the length, can you give me 6.3, the range? The range. Write down the range of F. What is the range of F? Range. You can check on your notes.
Y is an element of real numbers.
Check on your notes again. Check on your notes. The one that I just gave you now. What is the range? Check on your notes. We said the parabola range. There's a quadratic function. They're asking the range of F of a quadratic function, not a straight line, a quadratic function. Why?
Y is greater than Q.
Is it greater than? Check again. Check again. Is A positive or negative, Tendo?
So it's negative.
So what is the range?
Y is less than Q.
What is the value of Q in this graph? In this graph, the one that we're doing now, what is the value of Q? Tendo, what is the value of Q?
Q is a negative 4.
Tendo. What is the value of Q again? 6.1 f of x.
Oh, I think Q is a negative 8.
I don't see negative 8. I see positive 8.
Positive 8 side.
So Q is what? It's positive 8. So the range will be Y. It's less than 8.
Okay.
Did you do this topic in class, or is it the first time you're doing it?
We did.
Okay. But you didn't understand any?
No, not really.
Okay. It's fine. Means we'll redo it again tomorrow. But please go through those notes. Please go through those notes. Please go through them. They will
Okay.
help you. They are summarizing a lot of things. So when we talk about range, first of all, we need to look at the value of A. Is A positive or negative? Is the graph concave up or concave down? If it's concave down, the value of A is negative. So what is our range? Our range is Y less than the value of Q. What is the value of Q? There it is, it's 8. So here it's our 2 marks for free. Okay, now let's go back to 6.2. So they are saying FG is parallel to y-axis. So meaning FG is a vertical line. FG is a vertical line. So what are they looking for? They're looking for length. This is some of the things that we didn't talk about. Length of a vertical line FG. So we have the formula for a vertical line. We have a formula for a vertical line and a horizontal line. So the length, please take note of this. It's part of the question that you will find in your exam. It's free marks, Tendo. It's free marks. It's free marks. Length of a vertical line. A vertical line. Length of a vertical line will be given as length is equals to the value of y, or the value of y they were on top. So that will be the value of y at f minus the value of y at the bottom. That will be the value of y, the value of y on top minus the value of y at the bottom. That will be the value of y at g. You see fg, look at fg. The value of y on top, it's this one. The value of y at the bottom is this one. Are you with me, Tendo?
Yes.
So this is the formula to find the length of a vertical line. So whenever we ask you the length of vertical line, y on top minus y at bottom. Then length of a horizontal line. They didn't ask it here. Please take note of this. Length of a horizontal line. The length will be given as follows. X on the right side, the value of X on the right side minus the value of X on the left side. On the left side. So an example here of a horizontal length will be determine the length of BC. Determine the length of what? Of BC. Are you with me?
Yes.
So if we ask you the length of BC, this is the horizontal length. Do you see that? It's very horizontal. So the length of BC will be determined as what? It's X at C, because C is on the right side, minus X at B. If you check, this is 2 minus negative 2. That is going to give us what? 4. Okay. So the length of BC will be 4 units. If we can do it here, e.g., BC is equals to the length of BC. BC is your horizontal length. Will be X at C minus X at B. Because if you check, your C is on the right side, your B is on your left side. X at C minus X at B. So what is the value of X at C? The value of X at C, it's 2, minus the value of X at B, which is negative 2. Put in bracket, the answer is what? It's 4 units. Is it hard?
Not really.
Practice. So now we go to the question 6.2. Let's try to answer there. 6.2. 6.2 talking about a vertical length. So we'll write there 6.2 FG. It's a vertical length. FG, it's a vertical length. All I need from you, Tendo, it's practice. After this, you will have to redo these questions. I'll also give you the other ones. So 6.2 FG, 6.2 FG is equals to what? The value of Y on F. Remember, F is on top. It's a vertical length, this one. The value of Y at F minus the value of Y at what? At G. The bottom one. Okay. So let's go to the diagram and check. Do we have the value of Y at F? No, we don't have. Do we have the value of Y at G? No, we don't have. We don't have those values. Do you see? We don't have those coordinates. We don't have them. Your time is up. We don't have the coordinates of F and the coordinates of G. So we don't know the value of Y at F and the value of Y at G. But we know the input value. Remember, if you have the input, you can get the output. Remember, we said on the equation of f of x, which is equals to what? What was f of x is equals to what? Negative 2x squared plus 8. And then this is the equation of f of x. On this equation, we have indicated that f of x or y is the output, and then x is the input. X is the input. So f of x is equals to negative 2x squared plus 8. So I was saying on this equation, we know that f of x is the output and x is the input. So what we see here is that FG is parallel to y-axis, meaning the value of x at E is the value of x at G, which is the same value of x at what? At F. Do you see that?
Okay.
The value of x at E is the value of x at what? At G, because this is a straight line vertically, so meaning that if the value of x at E is what? It's 1. Also the value of x at F is 1, meaning the input at F it's 1. The input at G it's 1. So if we have the input and the process, this is the process, the function f of x is the process, then we can get the value of what? The value of y at F and the value of y at G. So the next that we need to look at is that, okay, we know the input at F, we know the input at G, it's 1. And so the next thing we need to know the function, the equation that it's working at F, so that we can know where to substitute the value of x, the value
Wait,
of.
please hold on. I'm trying to recharge my laptop, but it's not charging.
Okay.
Okay, it's charging now.
I was saying that the value of x at F, we know it's 1. So now we want to know what is the process or what is the function that it's working in F. The function that it's working in F, it's what? It's f of x. Okay.
Okay.
So meaning that if you want to get the value of y at F, we need to substitute the value of x, the value of x at F in which equation? In f of x. So meaning we can write here and say the value of y at F is the same as f of 1, meaning we've substituted 1 in F. We substitute x is equals to 1 in F minus, then let's go to G. In G, the value of x in G is 1. Therefore, what is the equation working in G? The equation that is working in G is G of x. Then it means to get the value of y at G, we need to substitute x is equals to 1 in G of x. Therefore, we'll take the equation of g of x, which is g of x is equals to, if you can remember, negative 2x minus 4. This is the equation that we calculated. So the value of y at g will be the same as g of 1. Remember here, we're doing this because we don't have the values of y at f and the values of y at g. We don't have those values. So what are we doing now? MSB. The value of y at g will be the same as g of 1. Then what does this mean? It means that we have substituted 1 in this equation. So we can also write it in this way. We say, okay, let's go to the equation. The equation is this one, f of x, f of 1. So it means this is negative 2, open bracket, 1, close, squared. Where there is x, we put 1, plus 8. This is f of 1. Do you see f of 1? What does it mean? It means that in f, where there is x, you put 1 there. That's what it means. Then minus, this is the minus, and then open bracket, you substitute 1 in g. That is negative 2, open bracket, 1, close, minus 4. This is g of 1. This is what it means to say g of 1. Okay.
Okay.
Then you can take your calculator and do your magic. Take your calculator and do your magic. So what we see here, it's negative 2 plus 8, that is 6 minus, let's see, negative 2 minus 4, that is negative 6. So open brackets, negative 6. What I see here, I find 12 units. Did you get 12 units here with your calculator?
Yes.
So that is the length of FG. So we do this in case we don't have the value of what? The value of y at F. or the value of YG. When we don't have the value of Y, we use the equations. All we need to know is the value of X at this point. Okay.
Okay.
So we use the equations. That is the vertical length. It's regular questions. These are questions that we expect in grade 10. These are regular questions. Let's go 6.4. A very nice question. Things that we can have a lesson on, but let's hope today we're dealing with greater than. Tomorrow we must talk about the less than. Must talk about the less than. So when we say greater than, look, greater than 0, that is to say positive. Okay.
Okay.
That is to say positive. So the next thing that I'm going to ask you to make this question very straightforward, and then you will see why it's 2 marks. F of X is Y. Do you agree, Tendo?
Yes.
And then when we say greater than 0, we are saying positive.
Mm-hmm.
Good. So it means what we are saying where is the output positive? Give us the values of X, the input values, for which the output will be positive. Is that, do you see that?
Yeah.
So they are saying the output must be positive. Let me show you the output. The output, where are you? Okay, here is the input. You see the input?
Mm-hmm.
And then your output is this one, is the function. This is the resulting here. Okay, let's use different colors. Let's use different colors. So in yellow, we're going to have the output. Okay, then in red, we're going to have the input. So the question is, tell us the values of X for which the function or the output will be positive. So let's see. Let me show you another thing. From this point, going down, the output is negative because the values are negative. Can you see that?
Mm-hmm.
From this point, going down, or going that side, I can put it in that way. Going that side, the output will be what? Negative. Can you see that? From this point, going that side, the output is what? It's negative. F of X is negative, not respecting or not answering to this rule. If I can also indicate here, from this point, going that side, the output is negative. Do you see that? It's on the negative side.
Mm-hmm.
And then from this point, going this side, the output is positive. From this point, going that side, the output is positive. It's above. So meaning the question was saying to you, tell us the values of X for which F of X is what? It's positive. It's above the X-axis. We look where the graph is above the X-axis. That's what our solution is. So our solution to this problem, it's this one. This is our solution. So what are the values of X? Let's check the values of X. If we were to do the number line, here for the values of X, the values of X, if we were to do the number line for our solution, where the graph is positive, if we were to do the number line gender, we're going to have 2 here and negative 2 here. Is that true?
Mm-hmm.
And then if we see here, we see that if we were to do our line here, we're going to say, okay, here you are. This is our solution. True or false?
I don't know.
Check. From 2, going that side. From negative 2, going that side. From -2 going that side, it's positive. From
Mm-hmm.
+2 going that side, the output is positive. That's what we're looking for.
Okay.
So our answer to this problem will be I believe it's new, but you'll get used to it. These questions are very regular questions. We'll say x is less than what? 2. And then x is greater than what? -2. So if we look at this inequality, we'll see that we are saying x must be greater than -2. If x is greater than -2, we are going to the right. And then if we go to the right, we see that the graph will be above the x-axis, meaning it will be positive. Do you see that?
Yes.
It will be positive if x is what is greater than -2 going to the right. And then if x is less than +2, the graph will still be above. Then the next thing is why didn't we put the less or equal to this? The less or equal to, why we didn't do that? Because on our question they didn't put the less or equals to. It's not there on the
So we
question.
only put it if it's included in the question.
Yes, if it's included, we include it. If it's not included, we don't include it. Okay. We must do more of these questions. Then we will enjoy functions. In short, Tendo, functions, it's 3 marks. I believe that if you go through everything that we did today, especially the notes, and try to understand them the way they are, there's nothing that needs to be added or justified. It's just straightforward. If A is positive, concave up. If A is negative, concave down. If M is positive, increasing function. If A is negative, the shape that I draw, it's telling you that if the shape of the graph is like this, then M is positive. You just need to check on those notes. So we have so much work to do. There's so much work if we can zoom out. So tomorrow we must be doing this. I mean, on Monday we must be doing this, and question 6. And question 6, yeah, still on the parabola. Yeah, on the hyperbola. I don't see the exponential, but we'll talk about it. Can you go and redo this question? Let's see what's happening here. It's a straight line and an exponential, so it's one of the things that we have to do on what? On Tuesday. Yeah, on Tuesday, not Monday. On Tuesday. Okay.
Okay.